Here are two examples where all we're doing is adding and subtracting, and we treat them very similar to equations. So I like to put my line right like that. It just emphasizes what are the two sides of my inequality statement. Here's s plus 18, so I need to do the opposite of adding 18, which would be subtract 18 from both sides, right like that. Okay, so I rewrite my inequality, and remember that if we're only adding or subtracting, then we actually don't need to flip the inequality. The only time you would flip the inequality is if you multiply or divide by a negative number. All right, so right here we have s is greater than or equal to, these would cross out, and they turn into 3 on this side, right like that. All right, so our final answer on this one is s is greater than or equal to 3. Okay, it does say graph this solution. So my graph would look something like this, and I would have a 3 right there, and it would be greater than. So I like to fill it in completely. Remember, if it's greater than or equal to, or less than or equal to, it will have a solid filled in dot. Okay, if it's less than or greater than but no equal to underneath, then it's an open circle. Okay, and then I ask myself, well, which direction will be greater than? So since s is greater than or equal to 3, I'm going to shade it larger, because technically this is 4 and 5 and yada yada. So I'm going to shade it greater than, which is in this direction. And that tells everybody that sees that graph that it is including 3 and larger for all the numbers that could make that a true statement. All right. What about this one? The x is on this side. No big deal if the x is on that side. All we do is we have two sides again, right? Here's my two sides. This I would read as negative 5.2 is greater than x plus 2. All right, and I'm going to solve by subtracting this 2 right here. Subtract 2. Cross these out because 2 minus 2 turns into 0. And right here I would subtract this one as well, and I get negative 5.2 minus 2 turns into negative 3.2. Then I would have greater than, and I would have my x right there. Okay. Wait. Did something wrong. Go back. Negative numbers. Okay, this is negative 5.2, and then I subtract 2. That means if I have two negatives right here, then I'm going to go more negative on the number line. Sorry, my head was in a bunch of different places at once. I was thinking about something else today. So right here I got negative 7.2 as my final answer. If I was to graph that, I would put negative 7.2 right here. Here's like negative, this would be like negative 6.2. Remember, as you go this way, it goes more negative. As you go less, it goes more negative. So this would be like, like negative 8 somewhere over here, negative 9, something like that, way over there. Okay, so which way would I graph it? Well, I read this as x is less than negative 7.2. Okay, so I go to my graph, and is it going to include it? No, it's going to be an open circle, and it's going to be less than, which means I shade it that way. If the variable's on this side, I have to be careful on how I read it. X is less than negative 7.2. Okay, so I go like this, and I shade less than, just like that. All right, a nice pretty way that it would look. Here, let me just click on the computer real quick, and this is how the computer actually shows their work with how it looks a lot prettier than I did it by hand. And you can see it's open like this, and the larger the negative number is, that means it goes less in that way. Like negative $100 in your bank account is a lot less money than even negative $1. So